Now we're going to talk about systems of equations that have special cases for their answers. So we have two different special cases. So we have two different examples. Let's start with number 4. Remember, we are focusing on solving by substitution today, so we want to find an equation that has a variable by itself. Well, it just so happens that our first equation has a variable that is by itself, and that's the y. So let's write the y equals 3x plus 4 for our first equation. And the negative 3x plus y equals 2 as our second equation. Since the y is by itself, we take what the y is equal to and replace it in the y in our second equation. So equation number 2 becomes negative 3x plus 3x plus 4 equals 2. Now that our equation is in terms of one variable, which is x, we can simplify and solve. So distribute and combine like terms. Actually, we don't need to distribute here. We can just take away the parentheses because there's nothing in front of them. So it becomes negative 3x plus 3x plus 4 equals 2. Now combine like terms. Negative 3x plus 3x. Well, that's actually going to cancel out because a negative 3 plus 3 is 0. So we're left with 4 is equal to 2. And that would be our final answer. However, remember the solution to a system is supposed to be an ordered pair where it has an x and a y. Well, our variables have canceled out here. So 4 is equal to 2 is a special case because is 4 ever going to be equal to 2? No. So our special case here is that the solution is no solution. Because our statement was false. And if you ever see this on a graph, no solution graphed on a grid would be when the lines are parallel. Now let's look at special case number 2. So looking at number 5, again write the equation that has a variable by itself. The variable by itself here is y, so I'm going to write that first. Y equals 3x plus 4. And then the other equation over here, and that is negative 6x plus 2y equals 8. So I take the variable that is by itself and look at what it is equal to and replace it over here for that same variable. So let's rewrite equation number 2. It becomes negative 6x plus 2 times 3x plus 4 equals 8. Now let's distribute and combine like terms. Positive 2 times positive 3x is a positive 6x. Positive 2 times a positive 4 is a positive 8. Bring down the negative 6x, bring down equals 8. And now we need to combine our like terms. So negative 6x plus 6x. Well, again, negative 6 plus 6, that's 0, so our variable will cancel out again. So we're left with 8 equals 8 as our final answer. And this is another reason why it's a special solution, because again, our variable has canceled out. But this time, instead of having a false statement, we have a true statement. So our solution here is infinitely many solutions. Or in other words, IMS. If you were to see this on a graph, instead of the lines being parallel, the lines would be the exact same line if your answer is infinitely many solutions. So in other words, you would basically only see one line there, but it'd be two equations that are graphed.